Hello, 30-1s. In this lesson, what we are going to do is get an introduction to solving trigonometric equations. Now, that sounds like it's going to be difficult, but it won't be that bad. What I want you to do before we begin this lesson is I want you to make sure you have a unit circle drawn out beside you, or your special triangles drawn out beside you. You need your graphing calculator. So make sure you have those, and let's get going. Here is my unit circle. Again, I would draw this thing out before I would attempt a test or a diploma. You're going to access it a lot. Again, just as a small quick review here, please, the equation of the unit circle is this. I like to write that down. We know any point on the unit circle is this. So the x value on my unit circle is cosine, and the sine value is y. Perfect. Now that we've talked about that, what we're going to look at is solving basic trig equations. Before we do that, let's go back and look at some basic equations that we were asked to solve in grade 11. Like this. Here's a quadratic. So it's an equation because it's equal to a value. And to solve it, what I liked to do a lot in grade 11 was to factor. And once I was able to factor, I was able to use the zero product property to say that either this one's equal to 0 or this one's equal to 0. So therefore, x was 3, x was 2. Let's think about this. The most important part of solving this quadratic was the factoring. Guess what? In 30-1, that's how we're going to solve these trig equations too. Instead of it saying x squared minus 5x plus 6, it's going to look like this. Sine squared theta minus 5 sine theta plus 6 is equal to 0. Now, before we get to those, like that looks scary, right? So before we get to that, let's look at a few more basic questions first, and then we'll get to something a little bit more nasty like that in a bit. So let's solve the following trig equations. Let's solve this equation. 4 sine squared theta is equal to 3/4, where 0 degrees is less than or equal to theta is less than 360. Now, a couple things I want to look at when I'm doing this. The first thing that pops out to me, and I need you to notice, is what mode we're in. We're in degree mode. So when we're answering, we must be answering in degrees. What does this 0 to 360 mean? Well, thinking of my unit circle, I'm doing 1 full revolution. So I'm looking for answers in 1 full revolution. Okay. Now go back to this other part here. It says 4 sine squared theta is equal to 3/4. Okay, so this is the equation that we're going to work with. Gotcha. Now, why did I put 2 4s there? Because I'm silly. Let's get rid of this 4 here. Okay, let's solve this thing. So our goal here is we're trying to get theta by itself. Okay, no big deal. What if this wasn't a theta, a sine squared theta? What if this had just said this? Well, I know what I would do in grade 11. I would divide by 4, and then I would square root. And I'm going to remember that I get the primary and secondary square roots, a positive and a negative. That's all I would have done in grade 11, right? So let's do this in grade 12. Watch, it's the same thing. I'm going to divide both sides by 4. I'm going to square root both sides. Positive and a negative. So now what we have to do here, that little extra step, my friends, is the question is really, what's theta, right? What is theta? That's what we're trying to do. What is theta? So I could, in grade 10, we would have sine inverse both sides, but that's not what I'm looking to do here. What I'm looking to do is to use my unit circle. So I say to myself, okay, sine is positive and negative. So I write down my little cast rule here. Sine is positive and negative. Well, that means we are going to have an answer in every single quadrant because sine is positive and negative. Then what I say to myself is on my unit circle, my sine is the y value. So we're going to go look at our unit circle and say, where is the sine, the y value, root 3 over 2, or where is the y value, negative root 3 over 2? Let's go look at our unit circle. All right, here's the unit circle. So where is the y value, root 3 over 2? Right there, right there. Negative root 3 over 2, negative root 3 over 2. And our domain that was given was in degrees. So our solution will be 60, 120, 240, and 300 degrees. So our solution is theta is 60 degrees, 120, 240, and 300 degrees. And I'm just going to put that in a solution set. So look again what we did. We essentially did the same thing we did in grade 10 or grade 11. Just now we have our different function. Instead of a function of x, now we have a function of sine theta. It's the same idea. All right, let's try another one of these. Once we get the hang of doing a couple, you'll be good to go for everyone. All right, let's solve cos squared theta minus 1 equals 0, where, notice our domain, 0 to 2 pi. Now we're in radians. So we have to answer this question in radians. We're also doing one full revolution of the unit circle. That will change sometimes. Okay, so I look at what I'm working with here, cos squared theta minus 1. Well, a couple different ways to do this. One way to do it is to just isolate for cos squared theta, square root both sides, make sure you get the positive and the negative. There it is. The other thing you could have done here was you could have factored this if you recognized that it was a difference of squares. And using your zero product property, we solve, and do you see that the two ways to do this give us the exact same answer? So now what I say is, what is theta? What values of theta, what angles give me cosine is positive negative 1? So I say to myself, cosine is the x values on my unit circle. Well, what values is that then? Well, cosine is my x value. So at 0, we have a value of 1, 0 radians. At pi, we have a cosine value of negative 1. And at 2 pi, we have a value of 1 again. There is your solution. Not so bad. Again, it looks scarier than it is. But as long as you've got that unit circle drawn out and you think to yourself, I'm just solving an equation, don't let the coses and sines or whatever trig functions in there scare you. You'll be just fine. Okay, let's try another one. All right, let's solve this equation. I recognize I'm in degrees now. Let's solve this equation. I'm going to do this wrong the first time on purpose because this is what I do not want you to do. And I see this all the time. I'm even going to change to big red because we know that's the international sign for wrong. I see this. Okay, I'm trying to solve for theta and I see there's a cosine on both sides. So I'll see this a lot on a first attempt. Let's just get rid of our cosines. Let's divide both sides. Okay. And what do we have left then? Well, sine theta is equal to 1. And we go and solve from here. All right. So what y value on my unit circle, what angle on my unit circle gives a y value of 1? All right. Well, theta then would be, sine is my y value of 1. That's when theta is 90 degrees. Okay, what's wrong with this? I'm about to show you. I'm going to attempt this question another way, and you will see what went wrong there. What I'm going to do on this one is I'm going to bring everything to one side. And now I'm going to factor a cos theta out. When in doubt, I like to factor. Right? We've been saying that all semester. Now let's solve this thing. Therefore, cos theta is equal to 0, or sine theta minus 1 is equal to 0. Well, sine theta minus 1. Well, hey, that's sine theta is equal to 1. That's exactly what we had over here. So what angle gives us sine theta is 1? Well, we know that's at 90 degrees. But notice the difference here. Now we have another set of solutions, right? We've got more answers now. So what angle gives me cosine 0? What angle makes my x value 0? Well, that's at 90 degrees as well, and at 270. So my solution to this is 90 and 270. What goes wrong in the first attempt that I did in red is this right here, this division. Do not divide out functions. You will lose answers. We lost the answer of cos theta is equal to 0. So when we divided it, we just lost one of our answers. Do not divide out functions. I cannot stress that enough. All right, one more to go, and you are set. All right, last question of the day. Solve this guy for part A from 0 to 360 degrees, and part B, something new for us known as the general solution. Well, let's do A first. First thing I want to notice is that this thing's in factored form. So I'm already happy. It's already factored. So I can start solving right off the bat. So therefore, we've got 2 sine theta is equal to 1, or we've got sine theta is equal to -4. Keep solving. Sine theta is equal to 1/2. And I'll just rewrite this just so it's at the same level. Sine theta is equal to -4. Okay, so use my unit circle. What angle gives me a y value of 1/2? That's what that says. What angle gives me sine equals 1/2? Well, sine is 1/2. We're in degrees here. So sine is 1/2 at 30 degrees and 150. Like it. Now, the next one, sine theta is equal to -4. I'm looking at my unit circle. -4. I don't have any y values of -4. Okay, no, we can't. The largest y value we can ever have on the unit circle is 1, and the smallest y value we can ever have on the unit circle is -1. So what this is here is a bit of a trick. Not a trick, but I need you to recognize that this isn't a solution. So what I want you to do is you're going to cross it off, and you're going to call this extraneous. It's not going to give us an answer. So I need you to do both. In 30-1, I need you to be doing both. Cross it off and write extraneous. So This is our solution. Okay, so we have two answers, one in quadrant 1 and one in quadrant 2. Now let's go and look at the part B here, the general solution. Okay, this is a little bit trickier. The general solution is you telling me all the answers if I had no domain. If the domain was almost infinite, I was going for an infinite positive revolutions and an infinite negative revolutions. Okay, that sounds a little complicated, and it is. So here's what I'm going to do first. I'm going to draw a pretty picture. Here's my pretty picture. It's a Cartesian plane. And I'm going to draw my solutions. There's one at 30 degrees. There's one at 150 degrees. So when I'm asked to find a general solution, what I'm going to see is, can I find a pattern to get to each of my solutions? So I'm going to do this. I'm going to say, okay, I'm starting here at 30. The distance from 30 to 150 is 120. Then I'm going to do this. What's this distance? Well, it's certainly not 120. You can see that's way larger than 120. What's that going to be? 240 degrees, I believe. So there is no pattern going between the two. So I can't combine my solution together. Okay, so I can't write it in a more elegant way. I can't put these two things together. Okay, I figured that out. So now what I'm going to do is I'm just going to write a solution for all possible answers. So I've got one value of theta is at 30 degrees. So what would it take for me to just get back to 30 degrees then? Well, I could do a full revolution all the way around, right? And that would get me back here. That would be at 390. Or I could have gone backwards. And that would put me at negative 330. Hey, isn't this just coterminal angles? Oh, you've actually done this before. So our solution here will be 30 degrees plus some revolution. N, I don't know what that revolution is, but I'm going to do a bunch of them. N, a member of the integers. And remember, in Alberta, for some reason, we use capital I. I'd be a little bit happier if we use Z, but that's the proper symbol for integers. So the integers part tells me that I could N, this number of revolutions, it could go backwards. So it could be negative. Okay, what's my other one? Well, 150. And again, I could do a full revolution to get around that circle. There it is. And I'm just going to write my solution brace just like that. There is your general solution. That is every single possible solution that is coterminal with 30 and 150. Pretty neat, hey? So when we get a general solution, draw a picture. Draw a picture. Now, what if there had been a pattern between 30 and 150? I'll show you. What if our solution from 0 to 360 had been this? We had found, oh, let's say 45 degrees and 225 degrees. All right. Well, again, I draw a picture. 45 degrees is over here. 225 degrees is over here. And I say to myself, what's the distance from here to here? Well, it's a straight line, so it better be 180. And what's the distance in degrees from here to here? 180. Oh, there's a pattern this time. So I can combine this into 1. So what I'm going to say then is theta is equal to 45 degrees plus, well, what's my distance to get to the next answer? 180. So plus 180 degrees, some number of 180 degree multiples, right? I could be adding 360. I could be adding 540. some multiple of 180, comma, n is a member of the integers. There it is. So a coterminal angle that we did way back at the beginning of the unit, we're seeing here again when we're finding a general solution. How I like to find the general solution is draw a picture. I think it makes it really clear to me if I can find a pattern between my answers. All right, if this thing had been in radians, well, I would have said this. If this was in radians, this would have been pi over 4 plus 180 is pi half n a member of the integers. So it doesn't matter what mode I'm in, friends. I just have to be making sure that I answer the question in the mode that it was given to me. Am I in degree mode? Am I in radian mode? Okay, there's your intro to trig equations. In the next unit, we'll do a couple other things. We'll do some more factoring, but the crux of it is just this, what you just did. All right, see you next time.